equal to the cos of theta, and then we have y is equal to the sine of theta, and probably y is equal to the tan of theta. So these are the three basic graphs that we shall be focusing on. And these are known as the mother graphs of the trig functions. So before we go into any details, sometimes this y could be represented using function. The function of x is given as the cos of theta. The function of x is given as the sine of theta. And besides the f, we can also use the g, we can also use the h, you can use the k, any alphabet for whatsoever case that will be used as a function is equal to something, sine theta, cos theta, or the tan of theta. So before we go into details, we need to also get to know some particular terminologies that are normally used. Number one is the amplitude. Amplitude is basically maximum displacement of a graph. Maximum displacement of a graph about a resting position. About a resting position, which position is always known as y is equal to 0, or basically the x-axis. So that is the amplitude, and we normally use letter A to represent the amplitude. Then we also have what we call the range, and the range is basically the y values for which the graph is valid, regardless of whether it's a tan, a cos, or basically sine. So y values for which the graph is valid or exists. So some values the graph can pass through, some values the graph doesn't. So we only need the maximum and basically the minimum points along the y. Then we have the period, and period is basically the length between repetitive patterns of the graph, between the repetitive patterns of the graph. So in other words, it's the number of degrees that are needed to create a full cycle. Or we can say degrees needed to obtain a full cycle of the graph. In other words, if it's a sine graph, after how many degrees do we get the full graph of sine? After how many degrees do we get the full cos graph and the full tan graph? That is what we mean by the period. So different graphs will have different values of the periods, but we have the standard ones from the mother graphs. And we know that the period, let's say of sine, will always be 360 degrees for as long as we don't have anything extra before the angle there. And then if it's a cos of theta, the period is also gonna be 360 for as long as there is just an invisible one there. And then when it comes to the tan of theta, the period will be 180 degrees. Now, what happens if, let's say, we have y is equal to the sine of 2 theta? We have something extra before the angle. So this 2 is going to affect the period of the graph. So for us to get the period of this graph, we shall have to divide 360 by that number, which is 2. Then the period in that case will be 180. Same story there. If we have, let's say, the cos of 4 theta is equal to 360, the period will be, if we have the cos of 4 theta, the period is going to be 360, the standard period, over the 4. So which means after 90 degrees, we shall have the full graph of cos. And then if we have, let's say, the tan of 2 theta, if we have the tan of 2 theta, the period will be 180 divided by 2, and then that will be 90 degrees in this case. So that is how anything before the angle affects the period, for as long as it is a multiplication. Any integer multiplied by the angle will affect the period of the graph. In other words, to reduce the period of the graph. Then besides that, there is the phase angle shift. What I mean is that if we have, let's say, y is equal to a, the sine of, I'll say theta plus a b. If this is the standard form given to you, we know that the first, or the coefficient of the trig ratio, which is the a, will always stand for the amplitude. And then this might be the normal angle, and then this b represents the phase angle, which is like the phase shift. So a phase shift is basically a horizontal shift where the graph is moved horizontally along the x-axis. It could be to the right or basically to the left. Now, if the graph is shifted to the right, the phase angle will be represented with a negative sign. So it will be sine of theta minus that phase angle. And then if the graph was shifted to the left, then it will be a positive sign to represent that shift. So that we have to also remember. And then what if we have a shift that is vertical? How do we notice that? So if we have y is equal to a, I'll use cos of theta plus probably q. For as long as we don't have brackets here between the theta and the q, then q is not a phase angle. It's basically a shift within the vertical. So if this q is having, so if q is positive, which means the graph is shifted upwards. And then if the q is negative, it has a negative value, a negative sign before the integer, then which means the graph was shifted downwards, equal to the number of units that are here. So if the q is 2, which means the graph is shifted 2 units, upwards or downwards, depending on the sign that comes after that. Then there could be scenarios where we have everything included. We have the b, and then we have the q. So there is a phase shift horizontally, and then there is a shift vertically, and then we also have our amplitude. So that we need to remember. Okay, what I'm going to do now is basically show us how we sketch these graphs, the sine, the cos, and the tan. So I'll use 35, and I'll use 35. Done. So let's say I need to sketch the mother graph. So mother graph is a type of graph whereby the amplitude is 1, the period is 360. It's more like the original basic graph or the primary graph. So if we have the sine of theta, and this is what we need to sketch, a number of methods can be used. Some people prefer using the table method. Some people prefer using the calculator directly. It doesn't matter, for as long as you have the correct graph. Okay, I have this as my y-axis. Then I have this as my x-axis. I can even make it longer. So if this is our 0, I can make this a 45. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Something like that. So this is a 45, and then that's a 90, and that's 135, it's 180, 225, 270, and then 315, and then 360. And then with my y-axis, can use intervals of 2. I'll say this is 0,4, this is 0,8, that's 1.2. Same 0,4, 0,8, and then 1.2. So that is gonna be a 1 somewhere there. So this is gonna be my positive 1, and then that's gonna be my negative 1. So from the calculator values, 0 is gonna go with 0, and then 45 is gonna go with 0,7, which is somewhere there. 90 is gonna go with a positive 1. 135 is gonna go with a 0,71. 180 is a 0. 225 is negative. These are negative numbers. Negative 0,7, which is somewhere there. 270 is a negative 1. Then 315 is 0,7 negative, and then 360 is a negative. And then I'll have to use my free hand and not a ruler to join these points. Join those points. Join those points with your free hand. Something like that. So this is the mother sine graph. So this is where all the sine graphs originate from. So, and that is the shape. So after 360, we have that wave. So in this sine graph, we have what we call the crest, and then we have what we call a trough, the top part, as well as the bottom part. Now, I'm going to use just the same line to draw the cosine graph. If I extend this a bit, and then I make this my y. So if this is a 0, sorry, that is my 0. I'll have this as my 0,4 negative, 0,8 negative, and then 1,2 negative. This can be my 0,4 positive, 0,8, and then I have my 1,2 positive. Then here I can use intervals of 2 blocks, 45, 90, 135, 180, 225, 270, 315, and 360. So these are the points. So that is my x-axis, which is going to represent my theta values, and then that's the y. Then what I can do, I can still go back to the calculator and start again with the mod table. This time I'll enter the cos of theta, alpha, and then the alphabet equal sign. I'll skip the g of x. My starting point is a 0, and then my end point is 360. And then my step is still 45 in this case. So 0 is giving me a positive 1, which is that point there. Use a different color. And then 45 is giving me 0,7, which is somewhere there. And then 90 is giving me a 0. 135 is giving me negative 0,7, which is somewhere there. 180 is giving me negative 1. Negative 1 is there. And then 225, I'm having negative 0,7. And then 270 is going to be a 0. 315 is positive 0,7. and then 360 is gonna be a positive 1. And then I'll join those points. I'll join those points with my free hand. So this will be the shape of the cos graph. So that will be y is equal to the cos of theta. So this is the mother cos graph that we talk about. So all the other cos graphs will be obtained right from the same kind of graph. Now, lastly, I will extend this again and draw the tan or sketch the tan graph. So if I extend this for my own safety, and then I have this, and go downwards out, not happy. I'll restart it again, maybe from here upwards. Okay, then I can label this as my 0 still, 0, 4. This is 0, 8, and then 1, 2, and then negative 0, 4, then negative 0, 8, and then negative 1, 2. Use the same intervals, 90, 135, 180, and then 225, 270, 315, and then 360 degrees. All right. So when I go back to my calculator, the mod 3, then I enter my function, which will be the tan of x, equals, I'll ignore the g of x. My starting point is 0. My end is 360. My step is still 45. And then I'll press enter to give me my values. Now, one thing we need to know, is that with the cos graph, with the tan graph, we always have what we call asymptotes. And these asymptotes will be formed at points where you see error or undefined. So in this case, if I'm to go on with my plotting, this is what I'm gonna have. My asymptotes are at 90 degrees. So I use dotted lines to represent those asymptotes. So the graph is not gonna pass through there. And then I have my 270 is also an asymptote. The graph will not pass through that line as well, or any point along 270. So if my x is 0, I'm having 0 for the y. And then if my x is 45, my theta is 45, this is gonna be a 1, which is somewhere there. And then if my x is 90, we say that's an error. And then if it's 135, we have negative 1, which is at that point. And then if it's 180, we have a 0. And then if we're looking at 225, 225 is gonna give us a 1, which is somewhere there. And then if we have 315, 315 is a negative 1. 315 is a negative 1. And then 360 is a 0. So what is left for us to do is just join those points and get the graph. So if I'm to start from here, this point of 0, and then that, so along the asymptotes, the graph must just be moving from the asymptotes towards the point, original point. Then here, I'll move from there, move this sort of pattern with my free hand, and then join towards the asymptote. And then this will move from that point towards the asymptote. So this is gonna be our tan graph. Now, just to take you back, If ever, let's say the sign or the coefficient of the sign is not positive, because now this one is like for a positive sine graph. If the sign is negative, then that graph will take a different shape, just the opposite shape. So it will be a different swing, but passing through more or less the same points of the intercepts, the x-intercepts, and then the y-intercepts will be the same. So something of the sort downwards. So that will be like the y with a negative. Then when it comes to the cos, if it's negative, instead of it starting from a positive one, it will start from a negative one. And then it will move in that sort of direction, get to the maximum point, and then move downwards in that sort of direction. So this will represent the negative cos. Then when it comes to the tan with the negative, then it will also change. Where this section was going up, it will start by moving downwards. Then this section will also move in this sort of direction, and then this section will move upwards. So that we have to remember when the A is positive and the A being negative. Now, with the amplitude, for as long as we don't have any number at this point, so in this case, we have just a one, an invisible one. So the maximum displacement, the graph is only reaching positive one. So this is our amplitude, which is a one. From the formula we said, get the maximum point, which is one, you plus the minimum point. Now we said we subtract the minimum point. So one minus the minimum point here of the graph, which is negative one, and then you divide by 2, which gives us a 1. Same applies with the cosine graph. You get the maximum minus the minimum, and then you end up with a 1 as the amplitude. Now, if ever we have y is equal to 2 sine of theta, which means our amplitude is going to be 2, and the graph will reach the maximum point of a 2. Okay, having said that, I want us to look at some questions. There we have our first question. In this case, they're asking us for the general solution. So when they ask for general solution is basically the general equations that can be used to determine any points along a certain graph or to solve any sort of given equation. So any equation that will fulfill the given ratio. So in this case, we have cos x minus 30 is equal to 2 sine of x. So we have different scenarios. It's either we create only one trig ratio, or we can create a quadratic, and then we solve those things using the quadratic formulas. Now in this case, on my left-hand side, I'll have the cos of x minus 30 being equal to 2 sine of x. So this sine x, this is the cos. So I can expand this using my compound angles. So that's going to be cos x, cos 30, since there's a minus, it will be a plus, sine x, and then sine of 30 is equal to 2 sine x. Then what I can see is that 30 is a special angle, so I can easily determine the values of 30. So we know that the sine of 30 is going to be root 3 over 2. Is that true? Sorry, the cos of 30. Cos of 30. The cos of 30 is going to be root 3 over 2. Cos of 30 is going to be root 3 over 2. So this will be root 3 over 2 cos x plus the sine of 30 is a half, is equal to 2 sine x. Then I can move this a half sine x that side so that they subtract each other since they are like terms. So I'll be left with root 3 over 2 cos x is equal to 2 sine x minus a half of sine x. So I'll be left with root 3 over 2 cos x. And on my right hand side, 2 minus a half, I'll get 1.5, which 1.5 is the same as 3 over 2 sine x. So I can get rid of these two, the denominators, and then I'll divide both sides by cos x. So this will give me root 3 over 3 is equal to the sine of x over the cos of x. But I know from my identities that sine over cos will give me tan. So tan x is the same as root 3 over 3. Now I need to get my reference angle. So it will be basically the arctan. So x is the arctan of root 3 over 3. And I use my calculator. That must be a 30. Shift tan root 3 over 3. Okay, then I'll look at this 30. Since this whole ratio is positive, and this 30 is in the first quadrant, we said in the first quadrant, all angles are positive. So the equation is going to be, or the solution is going to be 30 plus k times 180, since the period of tan is 180. And then k is a set of integers. Oh, I know that in the third quadrant, tan is also positive. And the third quadrant, it's 180 plus theta. In this case, our theta is 30. That will be a 210. So which means x is going to be 210 plus k times 180. And then k is a set of integers. Now, sometimes we use the k's, sometimes we use the n's. It doesn't matter. It's just a letter which represents integers, any numbers, integers between negative and positive. Okay, so those will be the solutions as per what the question is asking for. All right, and then 6.2. 6.2. They're telling us that in the given diagram, we have the graph of this cos x minus 30, and the g of x is that. So basically the solutions that we found, these have been turned into graphs now. They're telling us they are drawn within this interval. X is a set of 180 and negative 180. A and B are the x-intercepts. This is B, that is A of f. And then the G is given the two graphs intersect at point C. There we are. And then point D. Then the minimum and the maximum are the turning points of f. All right. Then they want us to get the coordinates of A. So coordinates of A, we know that A is basically the x-intercept. And what we know about the x-intercept is that y will always be a 0. So in this case, if we look at the graph of f, which is this one, the cos of x minus 30, we said our f of x is the same as y. You can do the substitution if you want. Then this will be a 0. And then we know that the arc cos of 0 will be x minus 30. So the arc cos of 0 will always be 90. Arc cos of 0 is going to be 90. So that's 90 is equal to x minus 30. Move the 30, then x is 120. So that is 120 and 0. And then the coordinates of C, we see that C is the intersection or the meeting point of the two graphs. Now from our general solution, those equations that we found do represent the equations where the two graphs will be meeting. So the first equation was telling us 30 plus k times 180. Now, if I replace k with a negative 1, so it will be 180 times negative 1 plus a 30, which will give me negative 150 degrees. So this point, since it's whatever is greater than negative 180, then it's going to be negative 150. That is the point. And then if I'm to replace k with a 0, it will be 30 plus k, plus 0 times 180. And that will give me a 30 degrees. So this point here will represent the 30 degrees along the x-axis. Then what we need to do, so what we need to do is, since we want the coordinates of C, you can replace C. Remember, we say the x is negative 150. And then if we have the sign of negative 150, we shall end up with a negative 1 for the y. So that's going to be negative 150 and then negative 1. Since we know the first point of negative 150, you can replace it anywhere. You can put it here so that you have the cos of 150 minus 30, which will give you the cos of 120. And then you get the answer that you want. No, we said negative 150, sorry. This will give us cos of negative 180. Cos of negative 180, which will give you the negative 1 there. And then 6.2.2, they're asking us that determine the values of x. Determine the values of x between negative 180 and positive 180, for which both graphs are increasing. Now remember, if we are to look at the graph of G, from this point up to this point, the graph is decreasing. And then from this point up to this maximum point, the graph is increasing. Same up, so this is the region of interest. The graph is increasing, because after that, the graph goes down. But here it's going up. Then when we look at the other graph, from this point, the graph is increasing. It's increasing up to that point. And then afterwards, it just decreases. So the question is asking for the values of x for which both graphs are increasing. So since below this point, or at negative 150, it's only one graph that is increasing, we need to determine this point where we shall have a minimum. So if this is 180, automatically that will be 90, and then this will be negative 90. So from this point of negative 90, we can see that it's increasing and it's also increasing. But after 30, the other graph starts decreasing. So we shall stop there. So we shall say that is between negative 90 is less x less 30, because at exactly 90 and 30, there will be no change. Then part B. So this could also be represented as x is a set of negative 90 and 30, something like that. Then they want us to get the values of x for which f of x plus 10. Now this is a phase angle, which phase angle simply means that I've shifted this graph of f 10 units to the left. And then the graph of G being shifted 10 units also to the left. Now, what's going to happen? Let me take this out. So what's going to happen is that if we shift this graph 10 units to the left, since this was a negative 150, when you subtract a 10, the C point will be negative 160. Since this was a 30, 30 minus 10, it will move backwards to something like a 20. The question is asking for the X values for which F is greater. Now, for a graph to be greater than the other, this graph must be dwelling on top. It must be above this other graph. So between, consider this one is on top of the G, just between those areas. Between those areas. So then we're gonna say that it's between negative 160, between negative 160 and then 20, and then 20. Or alternatively, someone can say negative 160 is less X and then less 20. Now, why are we not putting the equal signs? Because at the point where the two graphs will be meeting, they will be equal. The other one will no longer be greater. That's why we exclude the equal signs with this sort of notation. And lastly, 6.2.3. They want us to get the range. We determine the range where y is equal to 2 sine of x plus 3. So the original shape, let's say, was 2 sine x. You know that with this graph, the range is going to be the minimum value, which will be negative 2, and the maximum is going to be 2, because this 2 is the amplitude, the minimum and maximum values. Then what if we add a 3, which means this graph is being shifted 3 units upwards. So 2 sine x plus 3 will give us new values. So if we plus a 3 here, if we shift the graph upwards, we shall end up having 1 and 5 as our new values. So plus a 3 there, and then you plus a 3 here. And then now if we have 2 to the exponent of that, so we already have this graph and we already have its range values. So 2 to the exponent of 1 will give us a 2, and then 2 to the exponent of 5 is going to give us 32. So this will be the new y values, or the range values. So tell us that y is a set of 2 and 32. Or someone can say 2 is less or equal to y, less or equal to 32, since 2 and 32 are part of the graph. All right. Then the next question, they want us to determine the general solution of this. So 6.1, we shall say sine 2x is equal to the cos of x minus 30. Now the trig ratios are a bit different. It's upon me to choose which option might be quicker for me. So I feel like if I introduce a complementary angle somewhere here, I might end up with a sine, so that I have just a single trig ratio. Okay, let's see. So this is the sine 2x, and then I can express this as, let's say, the sine. This is gonna be 90 minus, have x minus 30. Does that make sense? So if I reduce this, I'll go back to that. Perfect. So then what I'll do, I'll just add the k times the 360. Doesn't matter. I can always do that even by the next step. So that's gonna be 2x is equal to I'll ignore this since the trig ratios are the same and then focus on just the angles. So that is 90 minus x plus a 30 plus the 360 times k. Then this and this is 120. I can move that x that side. So I'll have 3x is equal to 120 plus 360 times k. Now, I can divide through by 3 so that my x is a 40 plus divide by 3, I'll have 120 times k. And then we say k is a set of integers. Then that is within the first quadrant. And then I need another quadrant where the sign is positive. So what I'll do, I'll have 180 minus this whole simplified thing. 180 minus this whole thing here, because I know that sign is positive within the second quadrant as well. So then I'll have 2x is equal to the 180 minus this whole part if I take the x that side. So I'll say 180 minus x, and then plus my 360 times k. Open that up, it will be 2x is equal to 180 minus 120. I'll get a 60. That's a plus x plus 360 times k. And then I'll move the x this side. So x is going to be just a 60 plus 360 times k. K is a set of integers. So that will be the general solution, or those will be the general solutions of that question. Now, 6.2, the diagram below shows, is showing g of x, which is cos of x minus 30 for this sort of interval, 180 to positive 180 negative. Then they want us to write down the period. So remember we said the period of sine and cos will always be 360 degrees, doesn't change. So the period is 360 degrees since we don't have anything extra before the angles. So it will just start as 360. Then 6.2.2, determine the values of x for which the graph is increasing. The values of x for which the graph is increasing. So this looks like our minimum point, and then this looks like a maximum point. So from a minimum to a maximum, that is an increase. From a maximum sloping downwards, that is a decrease. So I'm interested in this x and then that x value. So we shall say that's negative 150 is less than x is less than 30. Or someone can just simply tell us that x is a set of negative 150 and positive 30 degrees. There we go. Then 6.2.3, they're asking us that on the same set of axes, we need to draw this graph sine 2x between those intervals. Between those intervals, we need to sketch another graph. So we want two graphs on one. So I'll get my calculator again and use my table method. So we said mod, you press 3 for table to give you f of x. Now in this case, my f of x, the naming doesn't matter. So that is sine 2x. So sine 2 alpha and then the x, close the brackets. And then now g of x, I'll ignore it. And then I'm starting from negative 180. Negative 180 for the start. Then press equals. The end is going to be positive 180. Then equals. my step. So when you look at this graph, it's from 0 to 30, then to 60. So I'm going to use a step of 30 degrees. And then I get my table. So with this table of mine, negative 180 is giving me a 0. So that point there. And then negative 150 is giving me root 3 over 2. Yet I know that root 3 over 2 is the same as 0.666. Sorry, it's 0.86. Root 3 divided by 2 is 0. Just a moment. Root 3 over 2. 0.866. So 0.866 can be somewhere there. We are estimating since the 0, this will be 0.5. So somewhere there. And then we know that, where is my graph? Where is my graph? Okay, and then we move on for the negative 120. This is off. Negative 120. Having the same point. And then negative 90 is a 0. Let me just do the long way or the quick way. So the sign okay. And then so the same point there. And then with the 90, I'm having a 0. And then with 60, I'm having negative 0.8, which will be maybe somewhere there. And then with the negative 30, it's going to be still the negative value. And then with 0, it's going to give me a 0. And then with a positive 30, it's going to be 0.86, which is somewhere there. And then with 60, it will be the same story. And then with 90, it's gonna be 0. And then with 120, we have negative 0.86, and then that, and then that. Then you can join those points. So I'll do this. That will be my maximum point. Drop this down. Pass through there, that's the maximum. Pass through the 0. That's gonna be my maximum. And drop this. Minimum. Something like that. So I'll make this bold. So this is my F. So in other words, we do not really want things that are accurate. So for as long as the intercepts are correct, passing through this and that is a mark. The shape is correct, that's also another mark. And then we also look at the turning points. Are the turning points at the correct point? So that is what we need. Then 6.2.4, they are asking us to determine, hence or otherwise, determine the values of x in this interval for which f of x times the g of x is less than 0. Now, what does this mean? So what this means is like it's either the graph of f or the graph of g being less than 0, but not both. So we need those points, the values of x, where we find either f or either g being less than 0, but not both of them being less than 0. So in this case, we can have from the graph, from the sketches, where do we find any one of them below 0? So we can say that between negative 180 is less or equal to x, less or equal to negative 90, because this graph is going to be less than 0, the graph of g, just up to that point. After the 90, both graphs, there is a section of both graphs being below 0, so we're not going to count that. Then from 60, g is on top at 0, but this f is below. So between 60 and 0, there's a graph that is below. So that is going to be negative 60 is less or equal to x is less or equal to 0. There's another section of the graph that is below 0. And then lastly, there's another section here that is below 0, between 90 up to 120. I'm going to stop at 120 because after 120, we are seeing both graphs being below 0. So I'll say 90 degrees is less or equal to x, less or equal to 120. So these are the values of x where f of x times g of x is less than 0. Remember we said it's either f that is less than 0 or g that is less than 0 and not both. All right. Then we have this other question where they're telling us that the function below sine 2x for the interval between 0 and 180. This is what we have. And then on this grid provided, complete f for the interval negative 90. So if we are to go back to our table method or calculator, or you can even use your substitution straight away. So there's a g, which I'll ignore now. So we're starting from negative 90. We are ending at positive 180, it's not a big deal. And then the step is 30. They want us just to complete this graph. So from my calculator, I'm having negative 90 as a 0. And then negative 60 as 0.8, which I can put somewhere there. And then negative 30 is still negative 0.8, which is somewhere there. So all I'll do, I'll just complete this, pass through that point, and then I'll have it done there. I need the maximum point somewhere here. And just go back. All right. So we say the maximum point at that point. There we go. So here is our maximum, so our minimum point. minimum point that there, then the graph is complete. So that we're done. And then on the same grid, they want us to plot this other graph, the cos 3x and stuff like that. So g of x, I'll enter the cos of x minus 30. Use whichever method you're comfortable with. The method that you're comfortable with. So step is 30 is done. Okay, so negative 90, just choose a different color. This one. Negative 90, I'm having negative 0.5, which is somewhere there. And then negative 60 is a 0. And then 0, negative 30 is a half. 0 for x is 0.8, which is somewhere there. And then 30, it's gonna give me a 1, which is there. And then 60 is giving me 0.8, which is probably that same point there with the other graph. 90 is 0.5, that point. 120 is 0. Then 150 is negative 0.5. And then 180 is negative 0.86, which is somewhere. And then I'll have to just join this with my free hand. No ruler. Until I get the maximum. And then I drop down. Okay, so I'll have something like that. So that will be my cosine graph. That would be my cosine graph. Then I can label that as G. Then they want us to calculate the solutions for this equation. So to get the solutions for these equations, they're in other words asking us for the general solution. So with the general solution, they go way deeper now because they want us to get the exact values between these intervals that this will be fulfilled or satisfied. So what we're going to do, like we did in the first case, we have the sine 2x. This can be changed to a sine of 90 minus sine x minus 30. Because remember, originally it was sine 2x equals the cos of x minus 30. So this can be changed into that. Then, and I simplify what is there. It will be the sine 2x equals the sine of 90 and that, which will give me 120 minus x. And then I can add my 130, my 360 and the k. So eliminate the sign, so it's 2x is equal to 120 minus x plus 360 times k for the first solution. I can move the x this side, which will now be 3x is equal to the 120 plus 360 times k. So divide both sides by 3, x becomes 40 plus 120 plus 120 times k. K is a set of integers. So alternatively, the other quadrant where sign is positive, we said is where we get 180 minus. So we're saying, we shall have the sine 2x is equal to the 180 minus the 120 minus x. Now ignore this. Then I'll only use the sine, the 2x. Ignore that, I'll use the 2x alone. And then my 2x is gonna be 180 minus that, which is a 60 plus x, and then plus 360 times k. Then move that, so x is the same as 60 plus 360 times k. K is a set of integers. Now, remember we said k represents any integers. So which integers are between negative? So if that's 0, this is 1, -1, you can even have -2, and then +2. So you can substitute any. But looking at my values of 120 and 360, if I replace k with a 0 from the first equation, if k is 0, then x is going to be a 40. If I replace k with a 1, x is going to be 160. But the moment I change k to a 2, then that will be a 240, and then that will be 280, which is out of range because we only want values between -90 and +90. Okay, then how about with the negatives? If I replace k with a -1, I'm going to have a negative. It's saying if we have 40 plus 120 times -1, that will give us a -80. K is -1, x is going to be -80. Replace it with this, it's going to give us -200, something like that, which is still out of range. Then I come this side with this equation of 60 plus 360. I replace it with 1, it's going to be way bigger. Replace it with the 2, it's going to be worse, so I cannot. But if I use k as a 0, x is going to be a 60. X is going to be a 60. And then if I replace with a -1, I'll end up having a -300. So that is also out of range. So my values of interest are going to be 40. I'm going to have a 60, and then I'm going to have -80. So this 160 is also out of range. I'll not take it. So this becomes the solutions of interest. So these are the solutions that are needed for this question. When they say calculate the solutions, that's how we do it. All right. Question number 6. Again, we have another scenario. They're telling us that in the diagram, we have a graph of f, x plus a within this interval. Then they're asking us for the numerical value of a. So this is a sine graph. And we know that a normal sine graph must pass through the 0. Must always pass through this, because sine of 0 is also going to be 0. But since there's a shift from 0 to a -30, so a is going to be a +30, since the graph was shifted to the left. So a becomes a 30 degrees. Then on the grid provided, draw the graph cos of 3x within the same interval. So I'm going to use this graph. I'm going to use that graph and probably my table method. So we have the cos of 3x. And then we're starting from -120. And then we are ending at +120. And then our step is still at 30, which is fair enough. So -120 gives me a 1. And then -90 is giving me a 0. Then -60 is giving me a -1. -30 is a 0. Then 0 is giving me a 1. And then 30 is a 0. 60 is a -1, then 90 is a 0, and then 120 is a +1. Plot those points and then join them. So if I'm to join this, I'll have something like that. It's gonna be my minimum point. Then I'll take it, that's my maximum. Bring it down, this is a minimum. Then I'll have my last point there. So that is my graph of f, sorry, of g. Then they're asking us to determine the general solution for f of x being the same as the g of x. So we can come down and say that f of x, we're saying f of x is equal to g of x. But our f is this. So that will be sine of x plus 30. The g of x is the cos of 3x. So then I'll have to create the same trig ratios. So I will change what is on my right-hand side to something like sine of 90 minus 3x, because I know that will reduce to a cos. Then I can ignore the sine ratios, so I'll have x plus 30 is equal to 90 minus 3x plus 360, the period of sine. I'll collect the like terms, then I'll have 4x must be equal to 60. When this 3 comes this side, it's a plus. The 30 goes that side, it's a minus. Plus 360 times k. Then when I divide through by 4, x becomes 60 divided by 4 is a 15. So 15 degrees plus 360 over 4, that's a 90 times k. And then k is a set of integers. So this is one of the solutions. But since we're talking about sine, the other solution must be in the second quadrant. So in the second quadrant, we shall have x plus 30 is equal to 180 minus all of that, 90 minus 3x. And then we can plus our 360 and the k. Just jot it again. So we're saying 180 minus 90 minus 3x. We close the bracket, plus 360 times k. Then open up the brackets and regroup. So x plus 30 is equal to 180 minus 90 plus 3x plus 360 times k. Then I'll move the 3x to this side, move the 30 to that side. So I'll have negative 2x is equal to, this is going to be a 90 minus 30, which is a 60, plus 360 times k. Then I'll divide through by -2. Then my x is going to be negative 30 degrees minus 180 times k. K is a set of integers. So those are the solutions for that part. Okay, and then 6.4. Determine the values of x within 0 and 120. So between 0 and 120, we need to find where f is greater than g. Where do we find f being above g, being on top? So it's between this area, between those areas. So since this was general solution, for the two equations. And we're saying these equations simply represent the intersection points. This will be our 15. It will be our 15 between 30 and 0. And then this will be a 90 plus 15, which is 105. So which means the values of interest are gonna be 15. So 6.4. We have 15 degrees is less x, and then less 105 degrees. That becomes the solution for that. And then 6.5, they want us to describe the transformation from G to another graph K. Which K is that? Of G. So we need to first of all know what is the equation of G. G is cos 3x. So how does this move from cos 3x to a cos of 60 minus that? So one thing we need to know is that if we factorize out a negative sign from here, it will be the cos of negative, then 360 minus 60. We say the cos of a negative angle will be the same as the cos of a positive angle. So it matters not. So that will be cos of 3x minus 60. Then from this, what if I factorize out the 3 that is common? Then it will end up being cos 3 into x minus 20. So that if I multiply this and this, I'll get my 3x. And then this and this is going to be negative 20. So what this shows me is that from the original graph of cos 3x, so this is representing our new angle. So it's like the new angle, there was a shift of 20 degrees. But on which side of the axis, left or right? So we said for as long as it's negative, it is a shift to the right. So the transformation is 20 units or 20 degrees to the right. 20 degrees to the right. So that is question 6.5. 6.5. Thank you very much for watching. Please like, comment, share, and subscribe. Thank you very much. Hello, welcome to this episode, and we shall be talking about the trig functions or graphs. So we have 3 basic graphs, and that is, let's say y is equal to the cos of theta,